Hey guys, what's up? It's me, PK Cubed, and welcome back to another video. In this video, I'm going to show you how the LCU works. So in the last video, I showed you how this computer can run programs, and today, I'm going to show you what's inside the LCU. So here's the LCU. It may look a little bit complicated. I'll have to zoom out to show you everything. That's a little too much. Basically, we've got our inputs on this side. So we have, actually, these are outputs. These are inputs on the top, and some of them are outputs, like the clock out or the counter out enable and the counter out. But some of these aren't even used right now because I'm still working on this. And right now I haven't actually finished all of the commands. As you can see, all of this memory stuff I haven't even gotten to yet. But anyway, here is our command input, and that just comes from the command ROM. And you can see it's being split out, and I have a blank one here just because it's nice to, because on the AND gates it's got a blank in the middle, so it's just nice to have everything line up perfectly. Anyway, basically, these data, the data 1s and 0, the bits, they go out and they split out, and then they go into each of these AND gates, and they all go into the same, and they all go through the same bus sort of thing, down to each and every AND gate. And yeah, so if we wanted to load A, like we did in the program, this is the first one, load A. So basically we have an AND gate, and each of the zeros we put in a NOT gate. So if it's a 0, it's going to be a 1 out the end, and then if it's a 1, then the AND gate will recognize that as a yes, and if they're all yes, then we know that it's the right command. So we have all NOT gates except for one, that's the one at the beginning. So if we do this, so you can see it's going to load through A. So if we look at this, load A is outputting to input to bus. So it also has to go into here and turn on the data, which is the data ROM. It goes through here, and then it turns on this controlled buffer, and that goes out into the input. So if we turn on load A just by putting in the right command, then you can see it inputs out, or it outputs 0. Now we could put whatever we want in the data, and it will output through the input. So let's just put a 5 in data, and look, there's a 5 in the input now. And let me see if I can, there we go. Now it says input. So that's basically how load A works. Also, it does go down and it turns on bus to register A, so it's just putting out the input into the bus and then bus to register A. Now, it's really handy to do it this way because you can just connect them to everything it needs to turn on. And with all these OR gates going to each and every one, you don't have to worry about colliding the AND gate and somehow going to what you don't want because it connects to another AND gate. All of these are separate except for when they connect each other through the OR gate, but they don't actually connect each other because the OR gate has like diodes on each of these, so they can't go backwards. Basically, load A just goes to input to bus. It enables, I need to label this OR gate by the way, it enables the input to bus, kind of like, yeah, I guess I don't know if I even need this, but maybe I do. Anyway, yeah, so input to bus is just going through here and here. Then it also goes bus to register A, and if we look at load B, it's going to do the same thing over here, but if we look down this wire, it actually goes to bus to register B instead of bus to register A. And that would make sense because it's loading to register B. So down here at, let's look at the register move. So over here in my command sheet, register move has some register codes or reg codes. Basically there's six of them here, and each one of them represents like which ones you want to move to or from. So let's look at the first one, which is A to B. So what that should do is go A to B. So it's going to turn on, it should turn on register A to bus. Let's see. So it goes here, goes down here, register A to bus. Then it also goes up here over here and bus to register B. So it's going A to B, just like it's supposed to. Now that happens with all of these other ones, and what's controlling these is I have some AND gates, and each AND gate is connected to the output of the command register move, and then we also have a command sort of thing coming out of the data. So if one of these data has come out, like 0, which is this one, if the data is 0, which it is, because this is green, light green, it goes into the first AND gate, and then that is also tied to register move. So if register move is high and the 0 code is high, then it will output onto register A to bus and bus to register B. A lot of hard words here. That happens with all of these, like I said. And so there's some other ones here, like if A is greater than B. Now I haven't done if A is equal to B or anything else. I just tried this one because it was a little bit confusing. Basically, I don't even know if I finished it. I don't think I have. Basically what it's supposed to do is if A is greater than B, it will jump to a certain program address, and that program address is listed in the data. So in the data of the current program line or byte, which is right up here in the data. So if it will just jump to this certain data, and it should put that into the input, and then it will go to the through the bus to the program. But I had some problems with that, so what I need to do is connect it directly. Oh, maybe I did do it. It needs to connect directly to the counter out, and that way I can just connect it directly to the counter, and it doesn't have to go through the bus when there's already stuff that we need to save in the bus. So, like whether A is greater than B. And the way it's calculating if A is greater than B is, let's look at this wire. So it goes out, after it finds the right command, it goes out, and it goes up, and it connects over here, and it goes into ALU to bus. So it's taking A and B, and it's either adding or subtracting them. And if we keep going up through this one, it looks like it's going to. Is that the right one? This one going. Yes. So it's going to bus to register C. It's also going to bus to register B. I don't think I. Oh, that's the wrong one. It also goes to add subtract, so it is subtracting. So it's subtracting A minus B, and then it's going to register C. Now, the output down here, if register C is, if the last one is a 1, then it knows that it should be negative, unless the answer is like 255, but it should work most of the time, and it's just checking if this bit right here, if that is a 1 or a 0. And if it is a 1, then it knows that it's negative, and that means that if it's negative, I need to put a NOT gate here. If it's negative, then the answer, it would, if it's negative, it wouldn't go to the certain memory address. So I do need to put a NOT gate there. Anyway, I need to fix some of these stuff in the LCU. But basically, this is kind of how it works. I think I should go over one more thing. Maybe I need to label some of these, because A plus B equals C is, no, sorry, that's fine. Everything's fine. But I don't think I've finished all of them. Yeah, I need to add A minus B equals C. Anyway, I hope you enjoyed this video about the LCU and how it works. So thanks for watching. Make sure to like and subscribe, and I'll see you later. Bye.